Sometimes, though by no means always, when we have a radical expression, we will want to simplify it to get a smaller index by putting our rational exponent in lowest terms. Usually, we do this because we have two different results where the roots have different indexes, and we want to see if they're the same, or how they compare to one another, or whether they can be combined. So, in general, this is something you should only do either because you're doing a math problem and the instructions say you ought to, or because you have some reason to want to be able to compare indexes. But this is something that we know how to do. The instruction for this will be something like rewrite with the smallest possible index. And in this first example, we are assuming that our variables represent positive real numbers. So we do not need to worry about absolute values. So we have the sixth root x to the fourth. That is definitely x to the power 4/6. Now 4/6, we can simplify that fraction by hand, right? That's 2 times 2 over 2 times 3. So that simplifies to 2/3. We could also use a calculator to simplify that fraction if we wanted to. X to the 4/6, that's x to the 2/3. That's the cube root of x squared. So the sixth root of x to the fourth is equal to the cube root of x squared, at least for positive real numbers. We haven't thought about whether it's going to be true for any other numbers. But we notice that this index 3, right, that's smaller than 6, we've rewritten this as a root with a smaller index. We've got the cube root of x squared rather than the sixth root of x to the fourth. So because we wanted to get the smallest possible index, that was why we did this. And now we have the smallest possible index is the cube root. Now, with variables, it's easy. With numbers, we have to first factor into primes. So 25 factors as 5 times 5. Here we have the fourth root of 25. That's the fourth root of 5 squared. With rational exponents, that's 5 to the 2/4. Now, 2/4, that's 2 times 1 over 2 times 2. So that's 1/2. This is 5 to the 1/2, which is the square root of 5. It seems like the fourth root of 25 is equal to the square root of 5. I feel like maybe that's something I'd like to check on a calculator as well. So I'm going to go to the calculator really briefly. I'm going to say, what's the fourth root of 5? So to get the fourth root, I go into the math menu. Say the fourth root of 25. That's 2 and a bit. Say the square root of 5. That's the exact same decimal. So throwing that into the calculator, we can see that that really does work. Fourth root of 25 is equal to the square root of 5. And again, we don't necessarily want to do that every time we have a fourth root. In this case, this instruction with the smallest possible index is what prompted us to do that. In general, we'll be looking at over here I have a fourth root of 25, over here I have a square root of 5. I wonder if those are comparable. And so we'll decide to simplify the fourth root of 25 in this way.